So section 2.7, back to solving equations. Solving equations in one variable. And we're going to be able to solve rational equations by multiplying by the LCD. And that's because when we talk about rational equations, we have fractions. And we would certainly prefer not to deal with fractions all the way through. It's not that we can't. It's just more complicated. So what we want to do is multiply by that least common denominator. That way we can eliminate the denominators of our fractions and just go back to normal solving. We do have to worry about extraneous solutions with these because they're fractions. And when we have fractions, we can't divide by 0. So we're going to get our answers. And then the first thing we're going to check is, is that going to make my denominator 0? Because if it does, it's out of here. But we also should check our regular solutions that are not going to make that denominator 0 to make sure they're going to work. So that's why I was loading up the graphing calculator earlier. Some of these get a little complicated. Some of them, it won't be a big deal to take our number, plug it in, and make sure everything works out nice. But some of them are kind of monster rational equations today. And we want to solve rational equations by using substitution and graphing calculator. That's probably going to be more along the lines of tomorrow when we do some word problem type of stuff. So top two objectives are really what we're going to hit pretty hard today. 2.7, solving equations in one variable. And it says solving rational equations, which fits right in with what we're doing. Rational equations are equations involving rational expressions or fractions. Remember, the set of rational numbers is represented by Q, quotient. Not going to need that a whole lot, but we need to know, hey, this has division taking place. Every rational equation can be written in the form some polynomial divided by some polynomial equals 0. So you get a 0 on one side. Because when we have solutions, they are the zeros. If f of x and g of x are polynomial functions with no common factors, then the blank of f of x are the blank of the equation. Well, they're the zeros. And what we're talking about here is thinking about those linear factors, x minus a or even just x. And those are going to be the solutions of the equation. So way back in Algebra 2, we talked about all of the math that gives us solutions, zeros, x-intercepts, roots, and how all of those words really mean you're doing the exact same math. They're synonymous as far as the math goes. But finding the zeros are finding the solutions. So to solve an equation involving fractional expressions, we multiply both sides of the equation by the LCD, the least common denominator. Clear away the fractions, make it a little easier. And like it says, sometimes the LCD contains variables. We should expect that for us at this level, we are going to see variables in our denominators. So there's a little baby rational equation right there. X plus 3 over x equals 4. And the directions say solve by clearing fractions. Well, we would want to do that anyway. So we have x plus 3 over x equals 4. And we'd rather not look at fractions all the way through, so we look for a least common denominator. What's our LCD for all this? X. So we're going to multiply every term we see up here by x. We know whatever we do to one part, we have to do the others to keep this equal to 1. So here we'll get an x squared, because this is the same thing as x over 1. So x squared plus, here the x's will cancel out and we'll get 3. 4x. Now, thinking ahead, that might be something that we could factor if we got everything over on one side. So let's subtract the 4x. Now let's see whether or not that's factorable. Now remember, that's always our first try. We don't go immediately to completing the square. We try to see if we can factor this because factoring is easier than completing the square. And to factor, we always say, hey, greatest common monomial factor I can pull out? No. Perfect square trinomial? No. Old-fashioned factoring? Maybe. Are there two numbers that multiply to 3 and add negative 4? What are they? Negative 3 and negative 1. So if those are the factors, on the last page it said, you find the zeros of those and you found your solutions. So most of us just look at this point and say, well, that'd be 3, and that would be 1, because that's what would give you 0. But every once in a while, we're going to find out we have something like this. And we're actually going to probably do at least a first step of algebra. I mean, most people in their head can say, oh, I'd subtract 7 and divide by 2 and do 7 halves. But not for this problem. This problem did not require that kind of thinking. So I have 3 and I have 1. First thing I check, is that going to give me a 0 in a denominator anywhere in my original? Well, no. 3 or 1 right here would be good. 0 would be bad, but we didn't get 0 for an answer. And then, of course, I want to know, are they right? Is this actually going to work? So if I put a 3 in here, 3 plus 3 over 3, does that equal 4? Is the question. Does it? Cool. Let's check. Then I go back and try a 1. 1 plus 3 over 1 equals 4. Does it work? It works. So we check it. And like I said before, you can check these with a graphing calculator, but this one, it would be totally silly to do this. The math is so basic. Just do it with the algebra, and you know, hey, these are both good. Those are both solutions. By the way, kind of a little stumper in the morning, I think. If I did graph this, where would I see the solutions? How am I going to know them when I see them on my graph? X-intercepts. If we get a 0 on one side, yeah. If we put the -4 over here, we can do that. What's another way we can see them? Visually. Yeah, the intersection. So we absolutely could do y sub 1, y sub 2, find the intersections. Now the reason I remind you of that, you just got a notice last night about the ACT testing. The MCA testing will be coming up. This could be a problem where you say, you know what, I'm going to turn my brain off for a second because my brain's been working too hard. I'm going to put this in as y sub 1. I'm going to put this in as y sub 2. I'm going to let the calculator tell me where that answer is so I can save my brain power for the next tough one. You know? Something like this, it's not going to take you long to solve it, but as we get to more and more difficult problems today, you're going to see that, yeah, and some stuff over at the graphic calculator when they take multiple choice tests, and that'll help out. All right, we have solving a rational equation. X plus 1 over x minus 4 equals 0. And we said before, hey, if we don't have to work with fractions all the way through, let's not. What's the LCD? Yeah, because this is over a 1. Yeah, it's x minus 4. So we're going to need an x minus 4 all over the place here. Well, the first term, nothing's dropped out. So we could go ahead and distribute that and make that x squared minus 4x. But, very nice, in the second term, that x minus 4 is canceled, and we get a 1. And over on the other side, we go goose egg, even better. So the first thing we would try is to say, hey, can I factor out a greatest common monomial factor? Nope. This might be a perfect square trinomial. The middle term doesn't work. In fact, you start thinking 2 numbers that multiply to 1 and add to -4. That ain't happening. So we're at the point where we should be thinking, well, I can solve any quadratic with completing the square. Move it on over. What number should we use to complete the square? 4. -4 divided by 2 is -2, and when you square it, you get 4. So this will be something squared equals 3. What's the something squared? X minus 2. What do you do to continue solving from there? Square root. So x minus 2 equals plus or minus the square root of 3. We recognize there's nothing we can do to simplify the square root of 3, but we're not quite done. That's all. Move the 2. this one, it's going to be a little more complicated. We've got 2 plus the square root of 3 and 2 minus the square root of 3. And yeah, going back up there in the original, that, might make you a little bit nervous to go ahead and do that. So with this one, maybe we want to check this with the graphing calculator. Well, if we're going to do that, we better know what decimal we're going to get with 2 plus the square root of 3 and 2 minus the square root of 3, just to be sure that what we see for our answer is what we're supposed to get. So we have 2 plus second square root of 3, which we should see as 3.732, blah, 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 on the calculator. And second enter, and just going to change this to subtraction so I don't have to re-punch the whole thing in. 0.26, about 8 to 3 decimal places. So that's what I'm expecting. Now, if I am grading your test paper, I need to know that you checked. So if you're going to check with the graphing calculator, you're going to have to do something like this to show me that, and just put GC. Best case scenario, you would give me a sketch of what you see, but sometimes you don't necessarily have time to do all that stuff when you're taking the test. So let's see if we can get those numbers from x plus 1 over x minus 4. Now this one, perfect example of why we would use a calculator. This is set equal to 0. So that means we want to know those x-intercepts. So I've got my x plus, and then notice I had to put the whole thing in parentheses. 1 divided by parentheses x minus 4. Now, if there's more than one term in your numerator, you've got to use a third set of parentheses to let your calculator know, okay, put all this stuff together. So I just activated this first one, and now I'm going to try Zoom 6, which I know should be pretty safe because of the 2 numbers that we just saw. Now we see 2 intersections with the x-axis. And we're hoping that's the decimals that we saw when we did 2 plus the square root of 3 and 2 minus the square root of 3. But second trace, number 2, let's see if it really is. So left of the intersection, enter. Right of the intersection, enter. Enter to guess. Look familiar? That's good news. Let's try the other one. Second trace, number 2. And yeah, this is going to take a while unless I go over here. Come on, Blinkster. Every once in a while I hit the spot where it keeps it moving. There we go. Enter on the left, enter on the right, and enter to guess. Is that the other one we saw? Good news. We got it. All right, so to save time for the next one, I am going to deactivate that graph. So, graphing calculator, check mark, check mark. There it is. In the future, if we want to check them and there's not a 0, well, we could always move everything over to one side and then find the x-intercepts. Or, like we were talking about before, find the intersections. Where are they hitting each other? That's not so bad. Now, we did not encounter an extraneous solution, which is, with rational functions, it happens quite a bit. So we're going to find extraneous solutions in example 3 and 4. Remember, these are false solutions. They don't work. And a lot of times they are the number that will make your denominator equal to 0. That happens quite a bit. But sometimes they just flat out don't work. So you do need to check them all the way. So when multiplying and dividing an equation by an expression containing variables, the resulting equation may have solutions that are not solutions of the original equation. These are called extraneous. That's our fancy word for they don't work in math. False positives. You know, you've done all the math right. You've got these beautiful answers. You go to check them. Don't work. For this reason, we must check each solution of the resulting equation back into the original equation to make sure the solutions we found are a solution at all. So how do you know when you should be checking? I mean, we've covered a lot of math this year. How do you know when you absolutely should check your answers? Well, we already know the answer to that when we talked about having to restrict the domains. Whenever we took an even loop, we had to check our answers to make sure that things were going right, because in the domain, they could produce problems if you get a negative. And then we know that we can't divide by zero. So that's the other time we absolutely have to check our answers. And this one is looking a little more busy. So first thing I think of is I can't see the LCD if I don't see all the factors in the denominator. So 2x over x minus 1, that one's all set. I can see the x minus 1 right there. 1 over x minus 3, yep, that one's all set, equals 2 over, hoping that's factorable. Even more than that, I'm hoping at least one of the factors that I have matches what they have up here. So x squared minus 4x plus 3, no greatest common monomial factor. It is not a perfect square. We are looking for two numbers that multiply to 3 and add to negative 4. 1 and negative 3. That is great news, because that means I'm not adding any new linear factors to the denominator. So bad news is we got to take both of them. We have to. So every term that we have here, all three of them, we're going to multiply by x minus 1 and x minus 3. Let's see what happens. First fraction, good news, we unload the x minus 1, but we'll have to distribute the 2x through x minus 3. Next one, we lose the x minus 3. We have a little x minus 1 times 1 up there. But in the back, on the other side, on the right-hand side, the x minus 1 and the x minus 3 cancel out. That is fantastic news. So I stop at this point and I think, okay, now what should I do? Well, it's a quadratic. We've got a 2x squared there, so hopefully I can factor this. If I can't, I'll have a backup plan, but let's get everything on one side and see. 2x squared minus 5x, and we'll have minus 1, but then we'll subtract 2 more over here. Excellent. All right, so if it's factorable, I would want to pull out a 2 first if I could. Yeah. All right, so now I know this is our least favorite type of factoring. What we have to do is try to find numbers in the front, first times first, that would give us 2, and then numbers in the back that would multiply to negative 3. The good news is there is not a lot of those. And it usually doesn't take us very long to figure out to get negative 5. We're going to need negative 6 plus 1. So outside times outside, negative 6, inside times inside, plus 1. There's the combo we need. And these came from first times first. And this came from last times last. Looks like so. Nice easy one here, 3. X equals 3. That is a solution. That is a 0. The other one, like I said, you might have to write it down like this, but then in your brain you go, oh, that's just a 2-stepper. Subtract 1, divide by 2. There they are. So now, we should have a problem. One of those might make our denominator equal to 0. Which one is out? Yeah, the nice easy one. It's out. Yeah. Most people, like I said, most people are not going to be as comfortable with fractions. So most people will just go ahead and eliminate the fractions and use the LCD. But there are so many different ways to solve. So if you are totally okay with fractions, you just keep the fractions all the way through. What some people do is get an LCD for the left-hand side, put those two together, and then solve this as a proportion and cross multiply. And there's a lot of different ways to go about this. make sure that what you have and how it works is very plain to me when I do it. Okay? Very obvious. So that's going to be the kicker. Make sure every step is there so I can see what you're doing. Alrighty, so we know the 3 is out. It is extraneous. What about -1/2? Well, we could do this by hand. We could put a -1/2 up here, and -1/2 down here, and -1/2 here, and -1/2 here and here. Most people are not going to like that, and that's a lot of fractions if you're going to do it by hand. You could kind of pseudo use your calculator to help you out with that, because you could change it to a -0.5 and put that in there. But probably, you know what, I'm not even going to tell you this is the easiest way. It's probably not. You've got a lot of punching in to do if you've got to check this with your graphing calculator. But they want us to do it that way. I would put the 1/2 in there. I'm just not that great at fractions. So I would put that -1/2 in here and see what I get as I go through there. But they did want us to check this with the graphing calculator. And I do need to show you that this is going to be different, because I'm not going to move this over to the other side and find the x-intercepts. I'm going to use intersection. So I'm going to have these as y(1) or y(2), whatever spot it's in up there, and this as the next one, and then see where do they hit each other. So this would be a really good one for you to practice. So like I said, I know I already have it up here, but I'm also going to punch it in on the TV calculator with you so that I can play along with it. As we're doing this one. Yes, you do have to check it. Absolutely. So let's see. We've got 2x over x minus 1. So I'm going to need one set of parentheses for the whole thing. 2x divided by another set of parentheses because there's more than one term in the denominator. So that's going to give me 2x over x minus 1, just like I want. Plus parentheses 1 divided by parentheses x minus 3, double parentheses. Enter. And then for this one, I have parentheses, and again, since there's only one term on the top, I'm okay with leaving that without parentheses, but I definitely need it for the bottom of this fraction. X squared minus 4x plus 3. There we go. And then we would try some good old-fashioned D6 and hope they hit you. So it's a little bit hard to see where the intersections are going to be occurring. But on this one, I think it's pretty plain right there with the red and the black. That's where they're hitting each other. And that's why we would use the intersection feature. So second trace number 5. And look at that. Blinky knew this is where the intersection is and went ahead and got there for us. -0.5 for x. That's the solution. So, I don't see that as the easiest. They wanted us to show you that so that you can see, yes, you can still use intersection. I would think the easiest way for any student at this point would just be to think of -1/2 as -0.5 and actually put it into all the x's and see it from there. But we would say x equals -1/2. GC, check. You know, we've got it. And we checked it with the graphing calculator. Yeah, see, now if we had to draw all of this and show all of that, that's going to take quite a bit of time when we're going through this. Anybody not have a color calculator? Some of you still have the old ones that have black and white? Yeah, it's a little bit tougher with those. And that's why I really think the easiest way to check this one is just think -0.5 and plop them in there, you know, and let the calculator do a little math for you as you go through it. But we do have to check. We need to check. Oh my goodness! Look at that one. Wow, that's impressive. Okay, so let's see what we should do here. Are all our denominators already factored? No. So let's take care of that. Alright, well now we've got it down. That didn't take too long. We've got a greatest common factor there of x. Hey, this isn't going to be that bad after all. What's our LCD? X and x plus 2, yeah. So this one, we're going to see the x's drop out. This one, x plus 2's will drop out. This one, best news yet, they'll both drop out. Cool. So x's are gone. We have x minus the quantity, x minus 2 times the quantity, x minus 3. Here the x plus 2's are gone. We'll have 3x. Here they're all gone. Lots of ones all over the place. And then we'd have to do some FOIL and see if we can put all of this mess together. So minus 3x minus 2x will be minus 5x plus 6 plus 3x plus 6 equals 0. And then we have x squared minus 5x plus 3x will be minus 2x plus 12. Whoops. Oh, thank you. Good gravy. Here I am with x minus 2 on that first one. I did it right on the other two. Thank you. Other two are good. Just a plus or a minus. Thank you. That would have messed that up big time. So x plus 2 times x minus 3 plus 3x equals plus 6 equals 0. Let's try that again. X squared minus x minus 6 plus 3x plus 6 equals 0. X squared plus 2x equals 0. Well, that's a lot nicer. So how do you suppose we can factor that? Take an x. So what are our zeros? So x equals 0 and x equals negative 2. Problem? What is the problem? Both of them? Both of them. They're going to give us zeros in our denominator. Okay, so what are we supposed to put? If the two answers we got by the second time around doing the math right don't work. Crummy problem, don't make us do this one. No solutions. But that, we better check. I mean, if we're going to say this doesn't have any solutions, we had better double check that. And that would mean, yeah, putting that all that ugliness in the calculator. Which means each individual little piece of those has to go in here. So we have parentheses, parentheses, x minus 3, parentheses, divided by x, parentheses, plus, parentheses, 3 divided by parentheses, x plus 2, parentheses, parentheses, plus, parentheses, 6 divided by parentheses, x squared plus 2x. Now, and that equals 0. So what we're looking for is x-intercepts for that monster graph. All that, and we get a straight line, a horizontal line. It's never going to hit the x-axis. So we put GC, check, got it, been there, done that, got the t-shirt, it isn't working. So, objective-wise, we were after solving rational equations by multiplying by the LCD today, with a little bit of work on eliminate extraneous solutions. 43210. How you feeling? Okay, if you agree with the statement, this is a lot like Algebra 2 at this point. Yeah, we did a lot of this in Algebra 2, so. Well, you shouldn't have any problem with that little baby assignment right there, then. Oh, you're going to that off and you're going to take a picture or something. It's probably easier. Seem easy compared to that nice analyze stuff we were doing. Yeah, they're time consuming. I don't think they're the most difficult things in the world. They're just time consuming. I checked it as